What is a balanced chemical equation? An equation in which every element has the same number of atoms, both on the reactant side as well as on the product side, is called a balanced chemical equation. The next question arises that why should a chemical equation be balanced? In order to follow the law of conservation of mass, a chemical equation should be balanced. For example, just see here, we have magnesium, one atom, and oxygen, two atoms on the reactant side. But if we look towards the product side, we have one atom of magnesium and one atom of oxygen. So, this means that the second atom of oxygen was destroyed during the chemical reaction. This would violate the law of conservation of mass. Hence, a chemical equation should be balanced. Now, let us learn how to balance a chemical equation. We'll pick up our same equation of magnesium burning in air. Here, we find that magnesium is reacting with oxygen, and towards the reactant side, first there is one atom of magnesium and two atoms of oxygen. Now let's move towards the product side. Here again, there is one atom of magnesium and one atom of oxygen. This means that oxygen is not balanced. So how should we balance it? Here oxygen is 2, and here in order to make it 2, we multiply by 2. But we cannot write 2 in between magnesium and oxygen, because then the formula will become different. That is why we have to place the 2 in front of the formula. Now when we do that, we've made magnesium also 2. Now here then magnesium was 1. So now what do? We multiply the 1 with 2 and get 2, so that here now before magnesium we are placing a 2. Now we have 2 atoms of magnesium and 2 atoms of oxygen towards the reactant side, and 2 atoms of magnesium, 2 atoms of oxygen towards the reactant side. Hence, we can see that the equation is now balanced. Every element has same number of atoms on both reactant as well as product side. Now, I would like you to have a look in your book at in-text questions 1, 2, and 3 on page number 6. Now, let's talk about the first question. The first question asks you, why should the magnesium ribbon be cleaned before burning? You remember the activity that we had done where we had burnt magnesium in air to form magnesium oxide? Well, in this activity, we should first clean the magnesium ribbon with sandpaper. Now, why should we do that? Well, children, magnesium is a highly reactive metal, and on the surface, it reacts with atmospheric oxygen and forms a layer of magnesium oxide, but only on the surface. So, we need to remove this layer of magnesium oxide in order to ensure efficient burning of the magnesium ribbon. Now, let's move to the second question. The second question asks you to balance the various chemical equations given. They are word equations, you have to convert it into symbolic representation. So here now, the first one talks about reaction of hydrogen with chlorine to give HCl. Now, if we look at the formula of hydrogen, it is H2, formula of chlorine is Cl2, and now here the answer to the reaction is HCl. But if the 2 is not written over there, then it is an unbalanced chemical equation. So, how do we balance it? We write H and Cl, the symbol of the element, and the number of atoms, which is 2 and 2. Now, we look here. Hydrogen is 1, and Cl is also 1. Now because there are 2 atoms of hydrogen, we need to multiply by 2 on the product side also. Again, because there are 2 atoms of chlorine on the reactant side, we need to multiply it by 2 here also. So basically this figure 2 will suffice to balance for both hydrogen as well as chlorine. So this is known as hit and trial method. Let's look at the second one, where you are told that barium chloride is reacting with aluminium sulfate to give us barium sulfate and aluminium chloride. Now children, the main thing is for you to remember what you learnt in the 9th class regarding the formulae. You already learned formula making in the 9th class, so you should be able to make the formula of barium chloride on your own by crisscrossing of valency, as well as the formula of aluminium sulfate by crisscrossing the valency. Then we have barium sulfate and aluminium chloride being formed. Again, this is an unbalanced chemical equation because if we look, we find that barium on the reactant side is 1